In 1936, an unidentified flying object crashed in Germany's Black Forest. Wingless, disc-like, and stronger than any man-made competition, it confounded all scientific analysis. Elite physicists from the SS Technical branch were tasked with recreating the mystery aircraft. In 1939, the Haunebu disc was born. The Thule Society was rumored to have a secret base in the Antarctic, and this is where the Haunebu disc was developed. Surprisingly, this notion isn't as far-fetched as it sounds. It was rumored that these capabilities were guided by higher knowledge supplied by ancient aliens. Contemporary media reports suggested that the aliens were working with the Nazis at the base, building liquid propellant rockets, anti-gravity discs, and stealth aircraft. With supersonic capabilities, the Haunebu was the world's first flying saucer. Jan van Helsing writes that scientists used psychic information from the Thule Society to create an aircraft that could travel at speeds of up to 12,000 kilometers an hour. During the Second World War, Air Force pilots spotted unidentified flying objects on numerous occasions. Reports described them as spinning balls of fire that followed fighter jets but never attacked. British Royal Air Force veteran Andrew Amrose wrote that when tracked, these aircraft would radically change speed or disappear, making them impossible to follow. Allied pilots called them Foo Fighters.
So how does it work? Well, it's similar to how a magnet falling through a pipe is slowed down. Anytime a conductor experiences a changing magnetic field, electric currents are induced in it which create a magnetic field to oppose that change. And in this case, the spinning magnets induce currents in the copper sheet. They create a magnetic field which is nearly a mirror image of the spinning magnets, and so they're repelled. If the rotors spin fast enough, this repulsion leads to levitation.
That is awesome.
All right, let's set it down again.
Yep.
So it's just going to come gently land.
The induced currents then encounter resistance in the copper, so they dissipate their energy as heat.
Yeah.
I experienced this before with another electromagnetic levitation device. Except with this one, the changing magnetic field was created by an electromagnet in the base, inducing currents in a light aluminum plate, which levitated.
Whoa!
The plate got so hot, you could boil water on it.
Check out how hot this plate is.
If you have two north magnets facing each other,
Yeah.
they normally just kind of like fall off.
Yeah.
Is there a similar problem here or no?
Not really, no. And the reason is the magnetic fields that are induced by currents in the copper sheet are a mirror image of the applied magnetic field, and the effect is so quick that as it moves, it just kind of follows it around.
Making this device work in practice is harder than it looks. For one thing, the magnetic field of the permanent magnets has to be very strong. Neodymium magnets are strong, but there's a special configuration you can use to make them even stronger.
It's called a Halbach array. They're used in particle accelerators. They're used in fridge magnets, actually. Halbach arrays, so they're stronger on the side that sticks to the fridge, so use less material overall.
Magnetic field lines run from north to south, and they're normally symmetric on both sides of a magnet. But if you rearrange them like this, the magnetic field lines are channeled almost entirely into one side of the magnetic array, and they cancel out on the other side. This configuration produces a much stronger magnetic field without changing the properties of the magnets. In these rotors, there are 12 wedge-shaped magnets. Their magnetic poles are fixed in this particular arrangement. This increases the magnetic field on the bottom side and almost eliminates it on the top. As the magnets spin, they create a rotating magnetic field in the copper beneath them. This induces currents that create magnetic fields which oppose the magnetic field of the spinning magnets above. The result is a repulsive force that is effectively lift for this quadcopter. But in addition to lift, there is also drag. Energy is clearly being dissipated in the system as the heat produced by the induced currents in the copper. And that energy comes from the fact the magnetic field of the induced currents is not a perfect mirror of the spinning magnets above. Instead, the induced magnetic poles are slightly ahead. So they produce a backward force on the rotors, which is really a backwards torque. And that's why the rotors on alternate corners have to spin in opposite directions. Because otherwise they would produce a net spin and turn the whole machine in one direction.
In that piece of carbon fiber, I've placed 6 little neodymium N53 strength, which is essentially the strongest magnets, and they're each placed with opposing poles. So you have north, south, north, south, north, south. What happens is when this spins right above the plate, it actually will levitate. It'll actually levitate about this far.
A lot of people are doing nothing more than getting huge quantities of mass and see if they can get a gravity wave to cause things to move. Well, that isn't what we're talking about at all. So I wondered if gravity could be related to its cousin magnetism. And so I found that when I take 2 magnets together, I have some neodymiums around here that I'm actually afraid of.
They're so strong.
They can danger you. But anyhow, you take a magnet, you go to put them together and they go clunk, right? But you take one of them, move it around, and all of a sudden it doesn't want to go together.
They're repulsive.
So I got I ordered one at $5,000 a piece, with a 1/4-inch hole through between both of them, and I put a brass bolt and I tightened them down, forcing them together. And then I put them together in a thing that looks kind of like a rock. Okay, and then I got another one that didn't have magnets in it. And Galileo, in all his endeavors, he went up to the Leaning Tower of Pisa.
And dropped the...
And he dropped a big rock and a small rock. And his buddy down the bottom kept telling him that the large rock and the small rock arrived at the same time. Well, I went up to in the Lockheed Building 501 by the side of escalators and elevators.
Oh, wow.
And I got 9 guys that were not educated and didn't have pre opinions on anything, and I dropped my 2 rocks, and I said, what I would like you to do is, I told them what I'd like you to do is I would like you to take whichever one arrives first, get it in your hand, and when I come down the elevator, hand it to me. Now they looked identical, except for
and nobody knew what was inside.
No, absolutely not. All the 9 times that I tested it, it's as though the one with the opposing magnet field extending out 3 feet on each side. I actually measured how
big the field is.
How big the field was, and on each side of one rock, I had a total of 6 feet. At any rate, the other rock arrived first.
Which one arrived first?
The one that had no magnetic field in it.
So you were able to cancel out gravity to a certain degree. You were able to cancel,
precisely,
reduce the mass gravity effect.
Precisely.
By opposing fields.
Isn't that nice? You bet. And got 9 signatures and I always get,
You did that at Lockheed? What year was this?
Oh, at least 8 years ago.
This is the actual document of Boyd's where he proved that by altering the field in a falling body, the magnetic field, it reduced its mass gravity equivalent and canceled out the effects of gravity to a certain percentage. And he did a building 500 drop test conducted from a height of 59 feet. The location is in White Solomon, Texas, and the time was 12:20 p.m. and this was in 1995, December 12th. Nobody knows this.
I know it.
So gravity, mass gravity is not, you can alter it.
Well, gravity within itself has to have, gravity goes through anything that is solid and anything like iron or anything else. But it has to have a magnetic component, which may be canceling out within itself. But as soon as it got around my rock, it all of a sudden recognized the presence.
How would you define gravity? Could you describe in layman's terms its basic principles for us?
Gravity is something difficult to explain because it's something that we essentially don't understand. It's just something that we can observe. Not much is really known about gravity. There are many theories about it, but they are just mainly theories. There's theories of gravitons, which allege that these subatomic particles that act like an attractive force like gravity that exchange between two pieces of matter. There is also a theory that gravity is a form of wave, an electromagnetic wave. Basically, gravity is a force. It's the inherent property of matter to have gravity, a mutual attraction for each other. Modern science, current science right now, identifies one gravity. It's one force in nature. Apparently, through research at S4 or information gained from one of the crafts they were researching there, it appears that there are two different forms of gravity. One form works on an atomic scale, on subatomic particles, holding pieces of matter, holding atoms themselves together. Another works on a larger scale, the scale we're most familiar with, holding planets in orbit, holding ourselves to the ground, things of that sort. Because it produces a gravitational field, I wouldn't say the craft is invisible during the day. However, if you're under the craft, because of the way the gravity is being used, gravity bends time and space, and it bends light. If you are looking underneath the craft or from certain vantage points, you will actually see what's above the craft. It's really a trick of the way light bends under the influence of gravity. For instance, we can see stars that are behind the sun, that are blocked from our view by the sun. The reason we can see them is because the sun is a tremendous gravitational field and it's bending the light around it where we can see the star. Space-time and gravity are all essentially interrelated. They all act on one another. Gravity bends space. Gravity also distorts time. When you vary one, you essentially vary the other two. As an example, if you have a massive body, say a planet or something that's making a lot of gravity, producing a lot of gravitational waves, if you will, it distorts space. It bends space to it. It also slows down time. These things aren't theories.